All right, now we're on to page 2, and the objective here is going to write the same polar coordinate in multiple ways. So let's go ahead and take a look at what we've got here. We're plotting 4 2 pi over 3. So of course this is our r, and this is our theta, right? Because we put it in the format r theta. Well, 2 pi over 3, let's go ahead, I put a unit circle here. 2 pi over 3 is right here. So it's at 120 degrees. So that's where I'm going to place my number line. So I'm going to bring it up to about 120 degrees, right about there. And go ahead and draw my number line. And it looks like here on the fourth one is where I'm going to have 4 and 2 pi over 3. So there is my plot point. Now, here's the question. Other ways to write it. So I want you to think of at least 3 ways to write it. Go ahead, and I'm going to give you a moment to think. And then I want you to turn to your partner and um, chat with them. Or if you don't have a partner to chat with, go ahead and just put it down on your paper of where you think this can happen. So go ahead and pause this video. Okay, so now we're going to come back and talk about the different ways that we can do this. When we have something like this, we know that the value of just moving here 2 pi over 3 is going to be the same as making one entire rotation and coming back to that same value. You could make 2 rotations, right? And then come back to that same value. So every time you do this, there's multiple ways that you could write it. So let's look at a formula here. So we've got r, and of course we have our theta, but then we're going to add a full circle, which is 2 pi, and then a letter we're going to call k. And k is going to be essentially the number of revolutions, right? So if I just want to go one time around, I'm going to do what I had in red. If I want to go 2 times around, I'm going to have what I had in green there. So that k is just how many different times you can go around that circle. If you have negative r, remember we put it in the opposite quadrant. That's the same as adding pi. So first what we're going to do is we're going to take that angle that was original in my coordinate, and I'm going to add pi to it to get it into the correct coordinate. And then from there, I can go ahead and do what I did before of 2 pi k with my original one. Okay, so that's how we're going to do it multiple ways. So for example, if I have 2 pi over 3, which is my original angle, and I want to add 2 pi to it, that's going to end up giving me 2 pi over 3 plus 6 pi over 3, right? I have to have a common denominator, because this is really 2 pi over 1. So I have to have my denominators the same. So 2 plus 6 is going to give me 8 pi over 3. So that's one way to do it. Let's go ahead and add 4 pi to it. So if I have 2 pi over 3 plus 4 pi, which would be 2 pi times 2. So my k would be 2 on that one. So 4 pi, and remember 4 pi is over 1 anytime you're just adding a value like that. So I have my original 2 pi over 3, and then I'm going to add to that um, 4 pi. So 4 times 3 is 12, so I would have 12 pi over 3, and that's going to equal 2 plus 12, which is 14 pi over 3. And you can keep going however many times you want, depending on how many revolutions you want to go around. All right. However, there's infinite ways to represent a point on a polar coordinate system. So that's something that's kind of interesting there. There's different ways that we could write it, but in a rectangular coordinate system, there's only one way. That one way is your x and your y. There are no multiple versions of x or multiple versions of y because they are actual points. They're not at a specific angle. All right, let's do some conversions. we're going to convert between polar coordinates to rectangular coordinates. And I did that real quick on the previous page, but we're going to go ahead and spend some time um, concentrating on it. Now remember we said that the y was the equivalent of opposite and my x is the equivalent of adjacent. And remember we have our um, trig functions, right? So we have opposite over hypotenuse are equal to the sine of theta. And then I have the hypotenuse with adjacent on top is equal to cosine theta. So some of you may have known these as like SOHCAHTOA or something like that. I have a tendency to stick it into magic triangles, and the reason is why is this. If I'm looking for the sine of theta, all I have to do is put my finger over the sine of theta, and I have opposite over hypotenuse. And if I need to find what the hypotenuse is, I put my finger over that, and it's opposite divided by the sine of theta. If I need to find my opposite side, I put my finger over that, and it's hypotenuse times the sine of theta. And of course, our hypotenuse here is r. So what I'm going to do is make a small adjustment, and instead of putting r here, or excuse me, hypotenuse here, I'm going to substitute it with r. So I'm going to do that in both of these magic triangles. So put r in there. And then instead of opposite, I'm going to go ahead and put y because that's my value for the opposite. So I'll put y. And then my adjacent side here is going to be my x value. So that's going to be x. So now what I can do is if I want to find what these are, right? I'm going to, let's see here, x is first. I'm going to put my finger over the x. And what do I have? R times cosine theta. So r times cosine theta. Oops, theta's not showing up real good. And then y, if I put my thumb over the y, and I have left r times the sine of theta. So r times the sine of theta. This will be true because as long as your polar axis is on your x-axis, your positive x-axis, this will be true every single time, every single time. So you want to make sure this is definitely something that I would stick in your little mini books when you look back and take a look at pre-calculus notes. All right, so let's go ahead and get to the bottom. We have 3 example problems. Convert the following from polar coordinates to rectangular coordinates. Excuse me, we have 2 examples. And I'm going to go ahead and stop this video here, let you guys take a moment to go ahead and work those out, and we'll do another video to show you how to do that.